one, workshop, IIiBF workshop. Okay, check this one. I have get your friend yesterday. Yesterday we used this one, SPSS. Today we are going to use AMOS. Everybody have this file? Yeah. You have? You have? Can you please share with me? Yeah. You have the file? No, but you can share with them, please. You have the file. Okay. Sister, you have the fire? You got the fire? Show it. Start, or you have to wait to download the software? Huh? What do you think? We start or?
Okay, for the sake of time, we will start and we'll factor in how we, during the break time at 11 inshallah, see how we manage to establish software while we are suffering down. So we can just follow with our notes while we, because initially we need the explanation before the practicals. Salam.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. So yesterday we have discussed how to use SPSS, right? With survey data or with social data. So now today we are going to use also structural modeling using AMOS. Okay, to analyze the survey data. And here, in survey data, actually, this is the information should be available in your survey data. You have to include the introduction, then the main topics of your research, then the demographic information of your...
Sorry, who else has AMOS on his or her laptop? You have? Do you know how I was saying that you may please share with your friends while we sort, so you may sit in the middle or something on each row if you have it? You get what I'm saying? Like sister, you may sit so that other sister there on that desk can share. You have it here? So this row can, at least while we're sorting for it. Sir, would you please sit here? Someone else beside you. Somebody has on this row. Do you have it here, anyone? You have it? Oh, mashallah, so that's covered. You want to sit here so that you benefit from it?
Of course.
Okay.
My laptop is broken.
No, I mean, this is the... Okay. And this room, I can still see how it looks.
So the problem. So usually in introduction, when you come to prepare your survey, you have to include. This is one type of questionnaire that's used for in survey data. So this is what you have to do. As I told you here, you have to write the introduction and you have to write the purpose of your survey. Why you want to do this survey, right? So in your purpose of your survey, just say like I want to do this survey for my PhD thesis. So then people will know that's your target or your objective of prepare this survey. Then who is conducting it? You have to also introduce yourself, right? Usually, you know, sometimes the university gives you letter, right? When you come to collect data. So this is what you need to include in that letter. So then the respect of confidentiality. Also you have to mention that in your survey, this information will be confidential. Information will not share with anybody, specific the information of the respondent. Then the time required and to complete the survey. So the main topic, this one which reflect your research. You are going to ask about the objective facts before asking more subjective questions. Your questions or your items should be more objective, not subjective. That means the question should be very clear. Then order the questions from the most similar to the list. Then also make sure that the answers to one question does not impact how the participants interpret the following questions. Then the demographic also. In demographic, usually we include such information like gender, age, income, nationalities, and geographical location, and education, and so on. So for conclusion, just to write the thanks for the participants. So here also you need to learn the level of measurement, how to measure the perception of your respondent. There is 4 scales to measure the perception of your respondent. There is a nominal, as we discussed yesterday. We said nominal for example, like demographic information, and like male, female, and this thing. Ordinal, you have to order categories. This you have to your data should be categorical. Then interval, like scales, the one we discussed yesterday, and then ratio. So this is what you, what should your survey include? But now we are going to learn how to analyze your data that you collect from your respondent. So there is also several steps like what we have discussed yesterday. There is like you have to learn how to key the data, and then to find and report the missing data, or we call it data screening. And then find and report the outliers. Then you describe the behavior of your variables. Okay. So we are going to, I think we will repeat what we have done yesterday. This one we have done it yesterday. So we repeat it today just quickly in order to get the idea of those who didn't come yesterday with us. So if you go to the file here, you open this file, workshop. So this is the data that we have in this file. Here we have the questions. I think everybody know how to key the data in the SPSS, right? Okay, so then we just go for the analysis. So here here we have two windows. This one, the view, the variable view and data view. In variable view, we have the information of the variables, right? Like the name of the variables, label, and also the values, and also here the measurement, which is the most important. This one, we said with the nominal, with the nominal and categorical, we use. For demography, we use nominal. For categorical, we have to select also categorical. For Likert scale, you select the scale. So then, here we have to know how to find the missing data, right? So yesterday we learned also how to do the missing data. Just we repeat it today again. We do analyze. We do it again. Here. You have to use this one, okay? Yesterday we didn't use this one because so you keep you move the variables from variable window to the analyze window. Then you just type here so here just make it 0.0001. Okay, here. Then you make okay. This one will give you the report for missing data. This is, if there is any missing data, it will appear here, because in my data there is no missing data, so then it show like 0 missing data, and the complete is 100%. This is complete with the blue color and the green color with incomplete data. And so, I mean here is a 0. There is no any missing data in my file. But if there is a missing data, let's say just here we delete such items. You go to the data, let's say here, we delete this data, okay? Let's say this is the missing data here. Now I do the analysis again, analyze. So you go to analyze better. So then it says here. See now, it gives me the percentage of missing data. This is 3.12. Okay, and this is the number of missing data. And then also here, the table looks, give you the mean and the variables. See here, if you go to your file, you will find the missing data with these items, and this the number of missing data, and this is the percentage. As we mentioned yesterday, if the percentage is more than 5, you have to keep it to keep the missing data here, or you have to drop them. If it is less than 5, you need to replace with the mean, and this is the mean. Give you directly here. This is the mean. Okay? In this table, they give you the summary of missing data. So in the this slide will give you the name of the items that the data is missing in. Then the number of missing data. Then the percentage. And the rule of thumb, if the missing data is more than 5%, you have to drop them from your data, or you need to replace the data. If it is less than 5, you need to replace the missing data with the mean. And this is the mean that you need to use. Okay. So then you need to show this report in your report, in your thesis for missing data. Okay. This is the way how to show your missing data. So now we go to the second step. So here we said what? First, you need to find the missing data and replace if there is any, if the missing data is less than 5, we replace with the mean. Then the second step is to check the outliers. To check if there is any outliers in your data. Because sometimes when you key the information in the, when you come to key your data, sometimes you type wrongly instead to write, for example, 5, maybe you write 7, or then that will lead to outliers. And also sometimes the respondent, when they answer your survey, some they just give 5, 5, 5 until they. So this one will lead to the outliers. So then you need to drop these outliers from your, you need to drop the case or the respondents of that guy who filled your form without giving any consideration. So then how to identify the outliers? We just go to here. There is such information here, you can delete this one from your data here, or this one you can delete it. Okay, you can just delete this information from there. So now what we will do, we are going to test the outliers. So for outliers, what you will do, you go to analyze, because see in the slide I have write all the steps for you. Okay, here in the slide I have arranged all the steps that you need to go through when you do the analysis. Just try to understand how to run it. Okay, the steps is already here. So now we go to check for outliers. You go for analyze. Then you go for linear regression, then linear, then you go to here, outliers first before you run the outliers, because when you do the outliers, you do it for the factors, not for the items. Okay? You do it for each factor. So that means first we need to find the mean of each factor. You need to generate the factors from the items. Like for example here we have, let me show you here. Like here we have SUB from 1 to 6, right? This one represents one factor. So then first you need to create the factors. How to create the factors? You need to do you sum from 1 to 6 divided 6. Then you get the average or the mean. Then you use it as the variables for your when you come to check for the outliers. So what you will do if you want to create those variables, you go here, transform, compute. Then you just write, for example, SUB. Then you go to the here.
Same variables or different variables?
No, transform, compute, Yeah, then write the name of the variables. Say SUB. Then you have to go to here, statistics. This one, statistical. You click on statistical, then you select mean. So now this is how to do the calculation. You select mean. So the mean will do what? They will sum from CB1 to CB6. Then they will divide it, divide by the number of items. Then you will find the mean. It's just very simple, like normal average, right? So this one you just do here SUB1. Then you click on the another, this one, the question mark. Then do the last one. So then the system will do the mean automatically by itself. If you want to do it manual, you can also. What you will do, you will write, you open bracket here, then you sum this one plus second one plus and then the number 6, then divide 6, then you will find the mean. But this one just they do it automatically for you. Easy, I mean, for you to
Mean there is automatical, or we should type the.
no, just type the test items and the second. Then they will sum it from here to 6. But you need to also arrange here your variables according to the sequence, like 1, 2, 3, 4, 5, 6. Okay? You cannot make, for example, 1, then you make here, there is 7, and then you take from 1 to 6. Then it will not consider the number 7. Okay? Or you write 1, 2, 3, then you didn't write 4, then write 5, 6. Then it will not consider the one is not in between. You have to write it according to the sequence number. Okay, so then you click OK. So, but for me here, I already create the mean for all the variables here. Or just we can just make OK here for these variables. Now, if you go to your data, you will find there is one variable already created here, right? So I will delete this one because I already created the new one. Then you keep this one, okay? So now this is the new variables that I created. The others variable also I have done it by the same way. So that means I create 5 factors from my data, because my data I have around I have around 40 items. But I'm not going to deal with 40 items. I will deal only with 5 factors. Okay? With 5 factors, which is the job satisfaction, payment, justice, promotion, and supervisions. This is my model. Okay? So now to identify the outliers, you are going to use these factors, not the items. Okay? What you will do, you go to analyze, then from analyze you go to regression, then linear. Okay? So now I just put here the dependent variables is job satisfaction in my model. Then the independent, the others 4 factors. Put them here. Now I don't need all this information as this moment. All this one I don't need. Just I go directly to save here. Save. I select Mohallanibos test. This test we use it to explore the outliers in our data. So you click on Mohallanibos test. Mohallanibos. Okay? Then continue, then OK. So now you go to your file again. You will find the system create new variables for you here. This one, MHA. Okay, this is the new variables created by the system. But this variable, when you check here, when you go to check the data of this variable, this is the information. It's arranged from the smallest to the highest one. Okay, but now I cannot say this one is outliers or not outliers. I need to find the B value or the significant label to determine this case is is outliers or not outliers, or this respondent is outliers or not. So what you will do, we go to transform, then compute. We do this one only to find the B value. So you write here B value or probability, PROP. Okay. Then you go to here, you click all. Then from here you select the confidence chi-square. This one. Okay, you select this one, chi-square. Now I got it here. So what you will do now, you go to your data here, the new variable that we created, Muhallanibot. We click on it, then it will appear there, right? So here, what you need to do, the degree of freedom, which means k minus 1. The k is how many factors you have in your model. We have 5, right? Then it will be 5 minus 1, it will be 4. Then I wrote here 4. You have to see how many variables in your model. Then you just, the total of your variables minus 1, then you put the figure here. So then, according to my model, I have 5 factors, then I minus 1, then it will be 4. Then you write here 4. So now I said okay. Now I go to the data. I will find the system already create new variable for me, which is the significant label. Instead to deal with those figures, I deal with the significant label. But the significant label here, you can make like, because the rule of thumb should be least than 0.0001. This is the rule of thumb to say there is outliers or not outliers. The B value of the case should be less than 0.001. So now this one only we have to dismantle. Then we try to you go to the variable view. From here you can increase the number of dismantle. Just make it 5. So now when I go back to the variables, I will find already the smell, right? But here you need also to arrange the data from the smallest to the highest. So here store ascending. So now it's the case already arranged from the smallest to the highest. If you see here, all those value is more than the rule of thumb, right? It's more than the rule of thumb.
Yeah.
So then there is no outliers in my data. But if there is anyone with less than this rule of thumb, then we record the case and then we drop it from. We drop the survey or the respondent from that respondent. We drop it from the data. See here, what you will do, I just show you like the real analysis for one student. So this one, you just report like this. Case number, okay? You have to write case number, the Mohalla Nibos test, and then the p-value. See all those, for example, when I run the data of my friend, then I found those values, the p-value is less than the rule of thumb. Then we record those cases, then we drop them from our data. Okay? How to find these figures? You just check from your data. For example, let's say here, this one. Let's assume this one is less than the 0.0001. Okay? So you go to the last column here. You will find the case number. This is the case number. So that means the respondent number 167. We have to drop it from our data, because when he answered our survey, he answered it without giving any real attention to the survey. He just just try to feel like 5, then give you the survey. You need to drop it from your data. If you keep it, it will distort your result, because it will not reflect the real perception of the people. So now it's clear how to identify the outliers. Yes.
For the factors, we need to include both dependent and independent variables.
Yes. You need to keep, because the outliers, you don't know whether it is from the dependent or independent. You need to keep all the variables here. That's why when we go to here, we want to analyze regression, then we go for linear. We check here, say, right? You see here, we got the dependent here, right? And independent here. Then we go for save, we check Mohalla Nibos, then we say continue, then you make OK, then you will find the variables already created in your data. Then the second step, after you find the variable created, we said we need to find the p-value, right? So to do the p-value, you go to transport, compute, then we select from here, we select all, then we go down here, we select the confidence, degree of freedom, chi-square. You select this one, you will find this formula here. You key here, you will key here the name of the Mohalla Nibos test that we found, the variable we identified. Here we do the k minus 1, which means the number of factors or variables in your model minus 1, then you put it here, then you continue and OK, then you will find the p-value. Then after that you compare the p-value with the rule of thumb. If it is less than the rule of thumb, you go and you drop the case. So after you drop the case, you need to report it in your thesis. And the way to report it, you just summarize it like this. This is the case number. This is the Mohalla Nibos value test. Then the p-value. Why we want to show the p-value? In order to say, according to this rule, this case represents as outlier. Okay? So now it's clear?
So how should I get this result?
This one. We said we take it from here, from the data. After we run this one, we will find, we go to the end here, you have two variables. Two columns here. This is Mohalla Nibos test value, and this is the probability. And the case number, you go to the first column, you will find the case number. Because when you key your data, you have to make the identity number for each respondent, right? So then you put the identity number there, then you will find the value of Mohalla Nibos test here and the probability. Okay? Let's say here, let's just give you an example. Let we assume this one is outliers, and this is the value. So what I will do, first I just copy this one, then I go to here, say here, include one, like this, right? So here I bought those two values here. Right? From where I bring this one? I bring them from here, right? This one and this one. Then for the case number, see the case number here, I don't have the case. So how to find it? I go to, this is the value that it's considered as outlier. So I go to the last or the first volume here. This is the identity number. Okay. Here the identity is not arranged because the system is, we ask the system to arrange based on the B value. Okay? So then we take this identity, we put it there. So this identity reflects to the respondent number 167. So this guy, when he answer our question, he answered it without any given any attention to read what we get. He just fill it to make you satisfied, and then you just submit to you. Okay, so then you need to report this thing. So according to this result, so here we make 176. So we just write it 167 or 76. I'm not sure. So you got it here. This is the case number. This is the Mohallanibos value. This one is the probability. So, but here, this one is more than the rule of thumb, then we cannot consider. But just I give you an example how to extract this table from your data. So then when you report this one, also you need to drop it from your data. You need to drop it. How to drop it? That's very simple. You go to your data. For example, let's say this one is outliers. Then I just click here. Then on the right side of your mouse, click. Then you make clear. Then it will delete. You just like you delete it from your data. Okay. So now this is the way how to identify the outlier. So what we learn now how to identify the missing data, then how to also identify the outliers. And then the second step is to describe your, because now no more outliers and there is no missing and no more outliers. So now we have to describe the frequency of respondent, like the demographic information. You need to describe how many male, how many female respond, the level of education, and so on. So now you go to your data for description. What you will do, you go here, analyze. Then you go for frequency. Analyze, analyze, descriptive, then frequency. Okay. So in frequency, now you need to key the items. Okay, you need to key the items here. You can key the items, also you can key the factors. There is no any problem. It's up to you. Let's say we key the factors here, just we got your job satisfaction, then justice, and then this is the 5 factors in our data. Then if you want also to, sometimes when you make the table, it's not enough clear for the reader to check how many male, how many female. It's better to make graph. Okay? Graph, or you need to make the plot to see. You go to chart, then you can select page chart or bar chart or whatever you want. Let's say we select page chart, then say continue, then we make OK. See, now this is the respondent.
So pie chart or bar chart?
Page chart, this one. This one is give you based on, like describe, for example, how many percent. If you want here, this one is based on the numbers. This one based on the numbers. If you want based on percentage, also you can do. You just say here, analyze, descriptive, frequency, then you select here, statistics, you select analyze, descriptive, then frequency, then statistics. You click here, press enter. Here, percentage, this one. When you go to chart, you select percentage. If you want percentage, instead of the numbers of respondent. Then continue, then OK. It will be true here based on the percentage. See here, for example, when we talk about sorry, here I didn't include the demographic because the frequency is for demography. That's why I was confused. So what we'll do, analyze, frequency, descriptive statistics, then frequency. So here, sorry, you don't need to include these variables. Include here, this one, the demographic variables, because I want to see how many people those. I mean, let's say in terms of education, how many respondents from PhD student, how many respondents also from master degree and so on. Then you make here chart. Let's say we take B chart, then we take percentage, then we click OK. So now we will get the result based on.
Yeah.
Now see here. This one is for gender. The number of respondents, male is 189, for female is 61. So this is the percentage, 75 to 24. 75% male, 24% is female. And also for the age, there is several category, right? And also for education. If you see non-qualification, we have 11 respondents. For diploma, 87. For bachelor is 129 and so on. So this is graphically how give you the numbers of respondents based on the graph. Okay? So this is the way how to describe your demographic variables. So after description, you need to here. Now we go for what we have done also like yesterday. We need to go for to test the statistical assumption. The statistical assumption should be achieved in your data before we do the analysis. Okay? Because if you didn't include, if you find one assumption is not achieved, also your estimation for your when you come to test your hypothesis will not be accurately. Then you need to first to test all those assumptions in your data. So what we will do now, we go to check first for normality. Okay, you check the normality. So for normality, just very simple, like what we have done yesterday. We go to analyze, because there is two types of normality. You need to do univariate normality and multivariate. Univariate, you make it based on each item. Okay, and multivariate based on the factors. So now when you do the analysis here, you go to descriptive, then descriptive. So based on the items, we call it univariate.
Descriptive, yeah.
Only analyze.
Descriptive.
Yeah, descriptive.
Yeah.
Then we select all the items. Why we do the item? Because we are we are going to do the normality test based on univariate. Univariate like for each item. Then option, from the option you select cortices and squamous. Okay? Because yesterday we just we learned how to describe the data, I mean how to check the normality, right? So also the same here. Now we said okay, we select here cortices and squamous. Because when you come to describe, when you come to check the normality, you have to check the squamous and the cortices values. This is the distribution of the data. This one is the mean. Should be 0. Then the distribution should be like this. This one is the mean, and this one is the positive side. This one is the negative side. Okay. So now, when we say squamous and cortices, this means the distribution of the data to the right side or to the left side. Okay? But when we come to talk about cortices, we see the highest value, because the rule of thumb for cortices should be not more than 3. This one, the rule of thumb here. If the cortices value is more than 3, then we consider the data is not normal distribution. Then we go back to the outliers test. Then we try to identify if there is any more outliers. Okay, if it is more, then it will be, the figure will be like this. So that means there is outliers in this mode. So now, according to this result here, oh sorry, first we need to keep all the data here. Only the items, okay?
Yeah.
Why we do the items? Because I'm going to test the multicollinearity, the univariate multicollinearity. Then just here, we set option. Okay, I already select this one. Continue. Then okay. So now this is the result. This is the result of squamous. This one is for cortices. You see here the squamous values, the statistical value. This one, all the rule of thumb in survey, for example, data should be more than 3. Sorry, it should be less than 3. And for the cortices, should be less than 5. Okay? If you check here, you will find all the items is less than 3, right?
Yeah.
All the values, which indicate that the data is normally distributed. For cortices, we say it should be less than 5. Now we check one by one, and then we find all of them is less than 5. Okay?
Sir,
Yes.
study says that because when we collect primary data, the rule of thumb is for skewness is +3 to -3. When it is secondary data, then plus -2
Plus 5.
for skewness.
For squamous, 3. This one here.
Yeah, 3 for primary data.
Yes.
And for cortices,
5.
5. Secondary,
Secondary is here for squamous, positive and negative 1.
1. Yes.
Yes.
And
For
cortices,
cortices, 3. 3.
3.
But for survey, because today we are focusing on the survey data, right?
Yeah.
So here, the rule of thumb, we said should be positive and negative 3. Okay? You can add here positive and negative because I didn't tell you. Positive. Positive. Just do it by yourself, huh? Negative and positive.
Absolute value.
Huh?
Consider absolute value.
Yes. So now it's okay. You can consider it positive and negative. But for this one, usually it's positive because the distribution only in one side. It's not like the cortices, the squamous. Because squamous, we have this side positive and this one is negative. Then the rule of thumb here should be negative 3 or positive 3. If this one is the accepted area, right? This one is the rejected area. So this is the way how to distribute. Describe your your normality. So for multivariate normality, what you will do? For multivariate normality, you just go here, analyze. Then you go to descriptive. Then descriptive. So instead of the items,
You see the variables.
instead of the items, you select the factors or the variables. The one we create last time, right? Just we put them here. So the same here, also we select only kurtosis and squareness, because those two tests to measure the normality. Then we said okay. Now this is the result. Squareness and kurtosis. See here the values of squareness is less than 3. So that means the data is normally distributed. According to the kurtosis, the values also less than 5. So then we compare our data is normally distributed. So then the first assumption is achieved, right? Because we said here there is several statistical assumptions. The first one is normality. The second one is univariate, multivariate, then examine the multicollinearity problem. Now we need to check the multicollinearity. And as we said yesterday, multicollinearity is mean what? There is a high correlation between two independent variables, which reflect there is like a redundant information in the model. So you need to eliminate the multicollinearity issue. That means if there is a high correlation between two variables, we need to drop one of them. So we go to check the multicollinearity. For multicollinearity, we use variance inflation factors or tolerance test. Okay? So here, variance inflation factors, how to test it, you just go here, analyze, you go to regression, then linear. So you key here the dependent variables and here the independent variables. Now we do it based on the factors, not based on the items, okay? We key here, this one we bring from here. We bring our dependent variables here, because according to my study, my dependent variables is here, job satisfaction, okay? My independent variables is supervisions, payment, and also the promotion. And what else? Justice. So this is our IVs. We call it independent variables. This one is the DB. Okay? So now this is my dependent variables. Okay? So now I want to test the multicollinearity. To test the multicollinearity, we need to use variance inflation factors or tolerance factors. Tolerance test. So what you will do first, you need to key here your dependent, then the independent variables here. Then you select entire, then you go to statistical here, statistics. You select collinearity, this one. You click on collinearity, then continue, then okay. So now this is now we go to check the collinearity here from this model, from this table. We have here the coefficient table. Then we are looking for what? The variance, inflation factors, and tolerance. You see here, variance, inflation factors, all of them less than the rule of thumb. What here? You go to the slide. The rule of thumb for collinearity should be less than 5. So now we go to check in our table. So here, if you check here, all the variables, all the independent variables is less than 5. This one, 1, 2, 2, 1. And the tolerance should be less than 1. And if you see the tolerance, all of them went something. It's less than 1, right? So now we compare, there is no multicollinearity in our data, which means we achieve the first, the second, the third assumption. Then we go to test, examine the existence correlation between the variables. So we said also the independent variables, they have to be correlate. But the correlation should be less than 90% and more than 0. Because if there is no correlation, so that means one of those variables, if we find like one variable doesn't have correlation with the other variables, so that means these factors or these variables is not related to this study community. You have to drop it from your model. So to do the correlation, just what you will do, you go to analyze, then you go for you go for correlate here. Correlate, then evaporate. So now you go to key the variables here. But here you shouldn't include the dependent variables, because correlation we use only between the independent variables. Between only the independent here. Because for dependent we will use regression to check the relationship between the independent and dependent. But between the independent we need to use correlation only between the independent. So then we key the data here. See, job satisfaction we are not going to include, okay? We just take from pay those only 4 factors. Here option, you just give it as it is, you don't need to change anything. Just select here person test, person correlation matrix test. Then said okay. Now this is the result of your correlation. See here, payment with payment between the relationship between PY and BY is 100%, and this is normal, right? Because the same variables, like the relationship between you and yourself, so it will be 100%, right? Because you are representing yourself. But between payment and justice is 66%, and then between payment and the promotion is 61. Then payment and supervision is 45. So here what we will say, if you check here, also the data here and here is exactly the same. The data is under the diagonal line, right? It's the same. So you don't need to consider the one is up the diagonal. Just you consider only the one is down. Because the same information. So if you check here, you will find all the correlation is less than 90, and all of them more than 0. So that means there is satisfactory degree of relationship between the independent variables. So now the fourth assumption is also achieved. If you find one of those factors has a high correlation, let's say more than 90, then you need to drop one of them, because this also an indicator for multicollinearity.
Drop the independent variable.
Yes, you need to drop it from, eliminate it from your data.
More than how?
90.
More than 90%.
Yeah, I already wrote here for you the rule of thumb. the relationship should be less. If it is more, you drop one of those factors. Then we go for examining the linearity. Same also here. What you will do? Yeah, you go to analyze, regression, linear. So for linearity, you need to draw the, here, you will do the same also. You do analyze, see again, analyze, regression, linear. Then we key here the dependent variables, here the independent variables. So what we need to draw the linearity. You go to plot. In the plot, you will here, the first Z predict, you put it with X. Then the Z residual, put it with Y. Because X represents the predictors. And the residual in the model is represent the residual of Y. So then you make a histogram and normality, then you just say continue, then okay. Now we go to check the result here. This is the linearity. So according to this figure, there is a linear relationship, right? Because the linear should be either positive, like this one is positive relationship. If it is in this side, like this, it will be negative. But the most important, the variation of this data should be together. Because if this one not linear, you will find each circle in different place. So that means there is no linear correlation. But when they are together, that means there is a linearity. So if there is a linearity, then you can go further for your analysis. If there is no linearity, that means the independent variable that you select doesn't have any relationship with the dependent. Then you have to go and for the literature to find the appropriate factors or variables. Okay? So now this assumption also is achieved. So then after that we go to test. Now after we check the data is, our data is, all the statistical assumptions have been achieved. Now we go for factor analysis. Okay? Because when we do we take break. You want to take break 5 minutes? Yeah. We take break, then we come back, we do the factor analysis. 5 minutes, huh?
So we all have the AMOS on our systems now? Anybody does not have AMOS? Okay, great. Everybody has it.
Flash, pin drive. Flash.
AMOS. Oh, who else does not have AMOS on his or her system?
So within this break, you can get your, you can get. So what we need to do, the exploratory factor analysis. Usually we use exploratory factor analysis to explore the factors, because let's say here when we distribute the questions, we don't know what is the factors of our in the data, because you cannot deal with 40 like here. This is, for example, this is my survey, right? And here, how many questions I have? I have almost 45 questions, right? So it's difficult to deal with 45 items in your data. Then you need to deduct this data. You need to reduce the number of items. So then the exploratory factor analysis will factorize those items to a small number of factors. Instead to deal with 45, it may deal only with 5 factors. Okay, this is the idea of explore the factors. Here you have the items, then the system is going to explore the factor for you, instead to deal with the items. Okay? So this is the idea of exploratory factor analysis. It's going to reduce the data instead to deal with several items. Here, the software will read the items and then will factorize them based on the self-perception. You will find, for example, the supervisions or the questions that is related to supervision. The system will put them in one factor. This is the idea of exploring the factors, exploratory factor analysis. It's going because here, you know, when you the first, I think this one, the first time when you create your survey, sometimes you don't know the factors. Like here, for example, I know the factors because I use this one from the literature. But sometimes you don't know these factors from the literature. Then you create those items by yourself. So then the system will help you to find the factors. The system will read the questions, and those questions they will represent different concepts. Then the system will take or combine all the items that represent only one concept, then make them under one factors. This is the idea of exploratory factor analysis.
So, if these items are adopted from other research,
You don't
do we
need
need
to do
to perform
exploratory.
it? We don't have to.
You just go directly for confirmatory factor analysis. But we do exploratory factor analysis when we run it at the first time. I mean, when we establish the questions by ourselves.
New idea, new,
Yes.
new theory.
You come with your own idea. Then you want to investigate this idea. You create the questions to measure the perception of the people about that specific phenomena. Then what you will do, you just write such question. Then you give to the people. People will respond to you. Then the system will create the factors for you. Because, for example, you write 45 questions to investigate that phenomena. Then the system will summarize each like 4 or 5 items together, because those items, they have some similarities and represent one concept. Then the system will factorize them. Instead to you have 45 questions, the system will make only factorize them to 4 or 5 questions. So the advantage of exploratory factor analysis too, they call it data reduction. It's a data reduction tool, like try to reduce the data from 45 items to only 5 factors. For for this the data that we have. But if your data, if your questions is considered as a replication from the previous study, then you don't need to do exploratory. You just go directly for confirmatory factor analysis, because the previous researcher already done the exploratory. Then he come already with the factors, and you are going only to replicate his questions, but for your case, right? So then you don't need to do again exploratory. Just go directly for confirmatory. Okay? So now we want to learn how to run the exploratory factor analysis using this SPSS. So I have summarized here the steps for you. Okay, all the steps. You see here, I summarize all the steps here. This is the way how to run it. I give you, I have draw everything from the software. Then you just follow the steps. So now when we run, you don't need to keep write everything. It's already here. Okay, just you try to focus how we run it now. And when you go back, you just try to practice what we give you in the slide. So we go to our data again. This is our data, right? So So in my data here, how many items we have from 2 till 30? Like I have 29 items or 29 questions. So then I go to analyze, we go to dimension reduction, then factor. Dimension reduction. Analyze, dimension reduction, factor. Then you click OK. Now you need to key all the items, not the factors. Okay, items. This one, like supervision 1, supervision 2, 3, and 10, the end of the item. Then you click on supervision 1. Then we drag all the items. You don't need to include here the demographic, okay? Just only the recursive scales items. So here we move them from this window to the variable window. So here now we need to focus which icon that we need to click on. You go to descriptive. In descriptive, what you need to select the determinants, the comma, and the image. 3. Determinants, comma, and the image. Okay? Then next continue. Then extraction. In extraction, you need to select here principal component, the first one. Then you keep the others as the default one. So then you go for rotation. In rotation here you have different tools you need to use for rotation. You have none, you have Varimax, then direct Oblima, and Quartimax, and then EQmax, and then Brumax. So here the most popular tools we use for rotation, we use Varimax. Okay? Most of the study use Varimax, but you can choose any one. Okay? So here we select, for example, Varimax. Okay? We select Varimax, then we click on continue. Then you go to the score. Here you don't need to change anything, just keep it. Then you go for option. In option you go to here, store by size. Or let's say we run it without store, then I will show you where we need to click store. Okay? So here also for this one you need to change the factor loading, the value of factor loading. This one is based on the sample size of your data. If your data is more than, let's say 300, then you can make the factor loading is 0.40 instead of 0.10. Okay, but if your sample size is high, you can reduce this one. If your sample size is less, you have to increase it. Let's say your sample size is 100. It's 100, right? Then you have to make this one at least 70. Okay? It's best
for 400.
There is a rule of thumb for this. How much percentage should be the factor loading? If you read the here 2010, if you go to the book, there is a rule of thumb. Like there is a table, and then there is the sample size, and then the factor loading. How much should be? Okay? You go to the book, then you will find the rule of thumb. But usually for AMOS, because in AMOS your sample size is in between 250 to 400, let's say. And for this one, you can just use 0.40. Okay, you can use 0.40. So here we change. We just put here 0.40. Then we just say OK.
.40.
240. 40, yes. Now, just here. You remember when I told you for store by size? See now how the data, when it's not stored by size, it's become like randomly, the data. Then you need to click there store by size, then this one will array based on the values.
So why we put the .40? What is it for?
This is the rule of thumb for factor loading. Should be more than 40. If it is less than 40, then that means this item is not load on that factor. Yeah. So analyze. Sorry. So just here I want to change this one. Sorry. Option. Then this one make store by size. Then we said okay. Now we just check again the result. See now the result here. This one, the determinants. So this, what they call it, those tests, they have a rule of thumb also for each test. How much should be in order to be, accurate.
Again, the doctor, analyze the deviation.
Oh, the analyze here. Analyze. You said analyze. Dimension reduction factors. Then you open this one. Then you keep the items. You move the items from here to the variable window. Then you go for descriptive. You select Como and anti-image and determinant. Then you go for extraction. You select Varimax. Then you go for extraction. What you select here? You select principal, sorry. Then you go for rotation, you select Varimax. You go for option, you select store by size, and then change the factor loading, 140. Then you make OK. Then you will find this result here. This one, right? Okay. So now this is the rule of thumb here. See, this is the rule of thumb for those steps. For determinants, the value, here, the value should be less than 0.001. Okay? Here, just write, the value should be less. Yes, value. Less than, where is this? Less than 0.0001. Okay, this is the rule of thumb. So here when we say determinants is referred to what? Determinants refer there is no multicollinearity between the items. Remember when we do multicollinearity for the data, we do it for the factors right there, right?
Yes.
Now we do the multicollinearity among the items. Shows there is no high correlation between the items. I mean, there should be a correlation, but not more than 90. So if this value determinant's value is less than 0.001, so then we consider there is no multicollinearity between the items. Now we go to our result, then we check. This is the result here. This is the determinant value. How much this one? Can read this value? This value is what?
0.
12 is 0.11.
6.06.
6.056. This is the value, okay. This means E, the error for 11, that means we have 10, 0. 10, then this is the figure. So this one is less than the rule of thumb, right? Because the rule of thumb is 0.0001. So here indicate what? There is no collinearity. There is no high correlation between the items. All of them less than 90.
Less than 90.
If you want to check, you can go to the data. If you see here, if you click, analyze. Just here, for descriptive, we can include here coefficient. See now, this is the coefficient and this is the determinant value here. If you check the coefficient here, you check all the values here, you will find all of them less than 90. There is no one is more than 90, which indicate there is no collinearity between the items. Okay? The values should be all of them less than 0.9. And if you check here, you will not find anyone is more than 9. Okay? This is the idea of the determinants value, the determinant test. So then we go to the second test, which is the COMO. This one, COMO and Bartlett's test. COMO actually test is referred to what? Whether the data is, your sample size is adequate or not. If your sample size is not adequate, the COMO value should be less than 60. But here the COMO value is more than 60, which means the sample size in our study is adequate. Because see how many respondents we have here in my data. I have 250, right? How to determine this 250 is enough or not enough? We have to use the COMO test.
It should be more than.
Yes. Yeah.
It should be more than.
Should be, the rule of thumb, this one should be more than 60. If it is more than 60, so that means the sample size that you collect is enough to investigate your issue. Okay? And here I have given you here the rule of thumb. The COMO and Bartlett test here that should be more than 60. But Bartlett test should be significant. This one. The Bartlett test should be significant. Okay? So then after that we go to the second step. We use the anti-image test. But anti-image take it based on, not based on the covariance, based on the correlation. And then take only the diagonal line, the one with A. See for example here. This one A, this one A. You take the diagonal one. This is the anti-image, is reflect the variables itself, how much is represent the concept, or because you know in normal situation we do for validation, for example, we use content test. We see with this whether these questions is represent the concept of the issue that we are looking for or not. Here when we check the anti-image should be more than 50, which means those items, the questions of those items is represent itself, or represent the concept that is he is represent for, or it is represent for. Okay?
Last time we saw the number one, which represent himself.
Yes.
Number one.
Yeah, but here not represent the concept of itself. For example, when I ask you a question, for example, when I said, let's say here in the survey, let's say here in the survey, this one. This is about what? Organizational commitment. Let's say this is the question. I am willing to put in a great deal of my effort beyond the normally expected in order to help this organization be successful. So this is what the content of these questions is represent the commitment, right? So this when we use the anti-image, we see whether this question is represent the content of itself or not. This is the idea. Okay? Because anti-image, like you look for the mirror, then you see yourself. So this is the idea of the anti-image. Okay? So then the rule of thumb for anti-image, how much? Should be more than 50. Now you go to check in your this one. You have to use the anti-image correlation. See here for the first, for the supervision one is 89, which is more than 50. The second one also 91, 88. Then you have to check all of them. You have to check the diagonal one with the A. If all of them more than 50, okay. If you find anyone is less than 50, then you need to drop that item. You shouldn't keep it in your data, because if you keep it, these items doesn't have meaning. You need to eliminate it from your data.
What about the first table? Covariance.
No, covariance you don't need to look for it. Just you look for correlation. Okay? So now this one clear? Okay, now we go to the second one, communities. So the rule of thumb for communalities should be more than 60. Here we check in our result. If you see here, this one is less than 60, right? This one less than 60. So we have two less than 60, which is supervision 1, supervision 1, then we have supervision 5. We have supervision 1 and supervision 5. And what else?
6.
What is?
Less than.
Oh, 6 also. Yes, so those items, we need to drop them from our data. We're supposed to drop them, right? Because if you keep them, they may cause a problem in your data. You need to eliminate them from data based on the communities. But in the literature, they said what? They said the communities, if it is more than 50, is still acceptable. Okay, in some literature, they said the communities, if it is more than 50, this is still acceptable. But if it is less than 40, you have to delete it. No, there is no way to keep that item in your data. Okay? So now we found two variables. It's not good. Or 3 items only. This one, the total variance explained. Also, the rule of thumb for total variance explained should be more than 60. So here it is 69, right? This one. Total variance explained. The total variance explained means how much those items can explain this model. Okay? Can explain by 69%. So now, if you see here, this one, the component matrix, we go for rotated one, this one. See now, the system explore how many factors for us? 5, right? When we key the variables, we key them together, right? Then the system factorize them, create 5 factors, and even make them based on the concept. Because this one Bayman, right? Or represent the Bayman. This one represent the justice. This one represent the promotion. Make them together. Why? Because the system read the concept and then make the similarity, the similar items together, and create one factor. This is the idea and the purpose of exploratory factor analysis. But here we have such issue. See, for example, what's the issue here? We have cross-loading. we have factor, the justice and justice 1 and justice 4. They are load in factor 1 and in factor 2. Then we have also SUP6 load in factor 1 as well as in factor 3 or factor 4. Then also justice 2 and 1 loading in factor 1 as well as in factor 5. Right? So this cross loading. This one also it will make a problem in your model. You need to eliminate those items. Like what is there? GS4 already here, right? No.
Factor loading should be more than 40%, right?
Yes. GUS. GUS4. Then GUS 1. Then from subtraction 1 and then from subtraction 2. What else? SUB. SUB 6 already here. Right? So those items we need to drop them from our data. Okay?
Why is that?
Because they have cross-loading issue. They load in different what they call it, in different factors. They didn't load in one factor. Because our idea here to find the factors, to the idea of exploratory to explore the factor. But these items has two, it's load in different factors. Then you need to drop the items. And then when you drop them, then you will find only each factors. There is we call it discriminate validation. Like each factor is different than the other factors. But if you keep those one, this will make like these factors is similar to these factors. Then which will lead to multicollinearity. Okay? When we come to the validation, we will face problem with those two factors. Because these factors represent both. These items represent both factors. So the decision for those factors you need to eliminate it. Any cross-loading you need to eliminate. Also, if the cross-loading is less than 40, also you need to drop. But if you see here, all of them more than 40. Why more than 40? Because the rule of thumb when we make the factor loading value there, see here. You remember when we do the analysis here? Factor, when we go to score, right? Option. We put here 40, right? So the one is less than 40, it will not appear here. Only 40 and above. Okay?
Can you repeat this? Please?
Here, you remember when we said absolute value for factor loading should be 40. The one with less than 40, it will not appear in the table. Only the one with the value above than 40. Okay? So now, what we will do, you can now drop those factors. But sometimes when you drop one factor, it will lead another, will cause another, what they call it, another cross-loading. When you run it again, because we do we call it rotated. We keep, we delete, then we run it again. We delete, then we run it again, until we eliminate all these issues. Okay? So, but what you will do, sometimes, let's say here now, we drop those factors. We go to analyze, dimension reductions. So now we need to drop them. This one is what? Here. This one is S4 and SU1. Sorry, just this here. Just this one, then just this 4. Then here we have SUP6. Then we have job satisfaction 1. Then we have job satisfaction 2. So now we already like eliminate them from the analysis. We return back to this window. They are not going to include it here in the analysis anymore. Then we just say okay. So now we check here. If you go to the common, it's still the same, right? So if we go to communities now, all of them, most of them is 60 and above. We go for total variance. What is total variance here? You remember how much the total variance, the previous one was? 69, right?
Yeah.
It was 69. Now it becomes 68.67. So when we drop 4 items, so that our 5 items, that 5 items doesn't have any value. If they have value, this one will drop sharply. But now it doesn't drop because those items is like represent redundant information. We don't need them in our model, right? See now how much 68 it dropped from 0.69 to 0.68, right? So which means like the value of those items is represent 0.01. So this means that those variables are not significant, are not we are not in need for those items in our model. We don't need them because it doesn't have any meaning or any values. Okay, so if you see now the rotated how much? How many items? So now we have 4, right? But still have such cross-loading. We have this one and this one, this one. So again also we need to drop them. But you see here how many factors we have in our model? 5. But now when I keep drop the cross-loading, my factors is become 4. So how to solve this problem? Then I have to check another tools. Instead to use Varimax, I can use another because they have 5. There is a 5 tools. Go to analyze, dimension reduction. Now I return them back because this one it will affect my model. So I go to rotation, then I use Bromax, for example. So then continue, then okay. If you go to total variance, it will be the same, 69. Then I go to pattern matrix. See now, no more cross-loading. Right? No more cross-loading, and I have also 5 factors. So that means I can use them without any problem, according to the Bromax tools or method. So this one together, the payment together, just test together, then the promotions items together, supervisions together, and so on.
So it means that each variables has the adequate items.
Yeah, this
so
one.
the items are representative.
This one now just give me numbers. When I go and read the questions, then I can write the name of this concept, and then I wrote it as a variables name. This is the idea. Now you have to rename. We call it rename the factors. Yes.
In the previous one, the mix among the items, for example, PY and finance of PRM together. That means I should use them as one variable or just.
No, you need to. You mean there is a cross-loading?
Yeah, in the previous strategy. For example,
You have to eliminate.
to Varimax.
Yes, use
No.
Varimax, you
Yeah.
need to eliminate them, but if you find, use the Varimax, but you find there is like your factors, like for example, sometimes you drop your, if you follow the Varimax, you need to drop, for example, the dependent variables. So then, what you want to study after if you drop the dependent variables, right? So then you have to try to use another instrument. Then you continue, because this will not be the final. You will go for confirmatory factor analysis. Then from there you can eliminate.
Yeah, my question was about the ordering. For example, here they order them by the order. Each items under one variables. But for the previous one, sometimes we can see some items for different variables.
Then you have to follow the Varimax.
The Varimax.
Yes. But you try. There is 4 or 5 instruments. You have to check each one. But the most appropriate is Varimax. Okay. But if your data, for example, your questions already replicated from the previous study, then use this one, because you don't need to drop here. You will drop them in confirmatory. But if your data is like pure data, the one who established the questions, then better to use Varimax and then try to eliminate, and because the system will explore the factors. But here you already know the factors early, because you already use the factors that have been applied by the previous researcher, right? But here, if you are the one who create the items, so then you use Varimax, then you can eliminate what any questions that any items has a cross-loading. But here is because I already know how many factors from the previous literature when I establish my model. So that means I'm not going to establish anything new. I'm going only to replicate what the people done before. Okay? So this is how to do the factor analysis. When you reach to this point, you have to rename. So I read what these questions is represent, then I put the name of that factors, the name of the concept. We say, for example, here. Let me read this one. This one, for example, see, participation in decision making. Okay, and this is the items. All those items talk about decision making. So when I read the concept, then I understand those questions talk about decision making. So my variables name will be decision making. Okay, this is the idea. When you come to the rename, this one is ready because we said this one we have extracted from the previous literature. But if you are the one who established the original items and you don't know the title here, what it is. So you read the concept because the system will factorize them together. The similar concept will factorize together. Then you go and read it. Then you put the suitable name for that concept. Then it will be the name of the factors. Okay? Okay, now let's go to confirmatory factor analysis. Now based on this one, based on this result, we have 5 factors. One is the payment, second one is the justice, then the third one is promotion, then we have the supervision and the job satisfaction, the last one.
So the items less than that have factors less than 0.40 are already deleted?
It will not appear here because when the absolute value for loading, we got it early. More should be more than 40. So the less than 40, it will not appear here.
I mean in variables view. So should we delete them from that?
No, it will not appear here. This is all the items. The value with less than 40 it will not appear. Please say here, I will give you another way to understand it. Just see here. If I make the decision, factor loading, I go and change this one. I put it 110. See now when I made 110, This is what is getting. Give me all the values. But if you see more than 40, you will find only the one is here. This one here 90, but here is less than 40. But because we already determined how much the factor loading be based on our sample size. Okay, because we said here, if it is from, you are going to use AMOS, then from 250 till 400, you can use 40%. But you go to the hair 2010, you will find the table. How much the factor loading for each sample size. Okay, now let's go to the second step, which is confirmatory factor analysis. So when we use confirmatory factor analysis, we use it when we restrict our items or factors from the previous literature. Why we need to use confirmatory, not exploratory? Because the previous researcher already make exploratory. I am just going to confirm. To confirm whether the previous literature, when he used those items, was correct or not correct. But when the first time I established the questions by myself, or the items by myself, that means I need to conduct exploratory. Right? So now, according to this result, we just replicate what the previous researcher do. So now we want to examine whether the previous researcher, when select those items, was valid or not valid. Then I use the confirmatory factor analysis. So here, confirmatory factor analysis is statistical techniques used to verify the factor structure of sets of observed variables. So rather than trying to determine the number of factors and subsequently what the factors mean as in exploratory factor analysis. If you already know or suspect the structure of your data, you can use confirmatory approach instead of exploratory. So the principle of measurement or confirmatory factor analysis, we need to examine two things: reliability and validity of your construct. Now we call those what? Construct or factors. We want to how to verify those construct is correct or not correct. You need to test two things: reliability and validity. This is the idea, because the previous one already explored. So now I want to examine the validation of those factors. So then there is two instruments. We use the reliability and validity to evaluate or verify whether those construct is valid or not valid. So for validation here, this is the for the validation and also for reliability. We have two type of tests. We use the goodness of data and also the logical validation. For goodness of the data, we use reliability test and also validity test. For reliability, we use two tests: stability and consistency. Okay, for stability, usually we use test and retest. What do you mean test and retest? For example, I give you the survey. Okay, I give you the survey, and then you are going to read, and you are going to answer the survey. Then I come to you, I collect the survey. After 1 week, I give you the same survey. the same person and also the same circuit. Then I collect your response again. Then I go and do the analysis, the reliability test. Then if I found the result is the same, so that means there is stability. Those items, they have stability to measure the perception of the responder. The second one is consistency. Consistency also the same. Like I do the test today and after 2 months, 3 months, I give you the same test, not necessarily the same person, any person. Then I may find the same result. So this represents the consistency. Another one is the validation. And in validation, there is also two. We have to use content and also we have to use the convergent validity. For content validity, when you create the questions, you have to get this to the expert people. For example, let's say you are doing research in Islamic banking. So you make the questionnaire, then you go to those professors or who work in the Islamic banking industry, you get them your questions. Tell them, please, can you evaluate my questions whether those questions represent the content of my issue or not. Then they are going to read it, then they will advise you. Okay, this one is valid, this one not valid. Like for example here, this one. When I gave this one for those who make in marketing, because this one is linked to the marketing. Those who work in marketing industry, they know all these things. So when I give them, they will read those items. If any items is not relevant to decision making, they will advise me to eliminate the items. This is the way how to evaluate the content. Okay. The second one is we do the validation based on this one. We said convergent validity. We use two tests: convergent validity and discriminate validity. Okay. Convergent validity, we use the CR, or we call it compensate reliability, to test whether those specific items here. You remember when we do the exploratory factor analysis, like supervision, it has 6 items, right?
Yes, sir.
Here. This one, the items, let's say. From 1, 2, 3, 4, 5. 6 items. Then the payment also has many items, right? So when we say here, convergent validity, so that's mean what? Those items only load for this factor. They are not loaded to another factor. So this one we call it compensate reliability. So those only represent one factor. They are not related to other factors. When we say discriminate validity means these factors is different than these factors. They have discrimination. And these items is belong to this factor, not to this one. So this is, we call it discriminate validity. If we use exploratory without this one, we don't need to go for this one because the system already explore, right?
Yes.
But when I do confirmatory, I want to confirm whether the previous researcher is doing these things or not. Okay, then I use the convergent validity to test whether those items is relevant to these factors. The second one also I use the discriminate to check or to confirm this factor, these items is not belong to others items. Okay, we call it convergent validity. Then here now when we come to test the convergent validity, you have to be familiar with those terms. We have observed variable, we have latent variables, we have manifest variables, and then residual variables, or we call it error term. We have covariance and influence, or we call it bad covariance. you have to be familiar with those items, with those terms. See now, when we say observed variables usually when we come to draw the framework of our model, we do it in like these figures. This one we call it observed. For latent should be circle. Okay, should be circle. For manifest, here one when we said latent should be indigenous variable. What mean indigenous variable? Indigenous mean the one is influenced by the other variables. Like here, when I say job satisfaction, this one is indigenous variable, and the other variable here we call them exogenous. Exogenous, the one is affect the other, not influenced by the others. If we say we have another variable here, then affect this one. This one it becomes indigenous, not exogenous variable. Okay, you have to be familiar with this thing. Then residual. Here each factors it has such items, right? And each item, we say this one the latent variables, and here we have the items. Then each item it has error term. This error term we call it the residual. You remember in SPSS when we started word display, we said y equals alpha plus beta x1, then plus beta n, then xn, right?
Plus zero.
Then plus the error term. This is the error term.
Yes.
So now why we need to use, for example, AMOS? Why we said AMOS is more suitable, or structural equation modeling is more suitable than to use SPSS, because in SPSS we assume we have only one error, and the residual only for y. But they say the researchers who established the structural equation modeling, they said no, each item has its own error. So then you cannot just rely only on based on one error. So that's why we need to use structural equation modeling. And also the limitation of using all S. Here we have only one y. Sometimes you have many y here. Many dependent variables, not only one dependent. Then you cannot test it using the what they call it, the OLS, ordinary least square. We need to use structural equation modeling. Okay?
Yes.
So now this is, we call it residual, or we call it the error term. Then covariance. Covariance is this one when it has two errors. Like this. We call it covariance. And path when it has only one direction, one arrow. This one is only between two latent variables. But this one is between the dependent and independent. This one is represent the hypothesis, the coefficient of hypothesis. This one covariance, which means the correlation between two independent variables. Okay? So now when we come to draw, you have to learn, you have to know which one, which figures you need to draw this relationship.
So there is the amount of influence part for it.
Yeah, this is the back coefficient, the influence, the one which represents our hypothesis. Okay, now let's go for analysis. We use the confirmatory. And see, this is the figures here. Observe latent variables, influence path, covariance. And this one is the error term. Okay? Then now we go for regression. We need to do the regression, but using structural equation modeling, not OLS. Okay?
Yes.
So what you will do, we go to you go to AMOS. AMOS file. So we go to here, you open this file. You have AMOS in your laptop, you click on AMOS. See here SPSS, because AMOS is working based on SPSS, right? So now this is the window of AMOS.
Which file?
Huh?
I think
You have AMOS or not?
yes, I have AMOS.
You just click on AMOS. You have AMOS? Yeah. You click on AMOS, then this is the Word file, the empty one. Yes. Now we need to draw the relationship that we want to examine. So here, when I come to draw my model, I have to draw it based on the framework, right? Based on the framework of my study. Here we have the dependent variables. Now I make it in circle, right? Because this represent what? Represent the latent variable. So it will be job satisfaction. Right? Then this one, it has many items. How many items for job satisfaction?
4 or 5.
You don't remember? Okay. Just go to the data for
Why?
Yes, we go to the file here. This one workshop, right?
Five.
5, huh?
Yeah, why?
Okay. So we call it GOS1, right? GOS2, GOS3, then GOS4, then GOS5. This is our. I'll just do it here. Analyze. So this is right. So now we need to draw this one actually. This is our exploratory. Now we want to examine the exploratory only. So we have here in job satisfaction we have five, right? This one, job satisfaction 2, 3, 4, 1. Then we have now the independent variables. Also, it is a latent variable. This one, the independent. This one, second, fourth. This one is say what? Here, supervision, right? Supervision, how many? Supervision, here. How many items? From 1 to 6, right? The same also, you will do like this. Like this. So here you will need CUB1, CUB2, then CUB3, CUB4, then CUB5. So then you will draw all like this. Okay, just I give you an example. We are going to draw it there. Then here your hypothesis, like this. Should be. This one we call it bath, right? Bath analysis. H1, H2, H3, H4. This is like your framework. Here we have supervision, justice. Then we have what? Promotion. Environment. So this is your model or your framework. Also, you need to learn all the items, and each items there are 10 here. This one we call it E1, E2, E3, and then A. Okay. So that's what we are going to draw now. There. See here now. We go and we draw it in AMOS. So to draw first, in order to draw the Latin, you need to use this one. You click on this one, then you come here, you write 1, 2, 3, 4, 5. Okay, this is our
Copy paste or
you can make copy or just one type.
Circle on that.
Here, let me just show you. No. Just click on this one, then put it here.
drag.
Now you go to this machine here, the photocopy machine here. You click on it, then now just make like this. This is my factors, right? I have 5 factors. If you want to move it like you use the lorry, drive it like this.
It's no function.
Huh?
It's not working. It's not working.
Which one? Which one?
Yeah.
For me.
No, it's there. I think what is. No, it's there. But this one, the color, I think. It's not working. Click when you press. So everybody is working with him. So now we continue, right? So you just make 5 circles. Done, huh? Okay, now we go to this one. We go to this one. This figure, you click on. Then you come to here. Let's say this one, the first one, right? How much items we have? Okay, let me check from the word file.
Payment, we have 6 items.
How much?
Doctor inspection has also 6 items.
Okay, let me just write it here.
Justice,
This one.
5.
So we have here job satisfaction. How many items? 5, right?
5.
Then we have payment.
Payment 6.
Then
Payment 6 no.
justice.
Payment 7.
Justice from 1 to
6.
EY 7.
6, right? Then
Payment
promotion.
Payment 7. Justice 6.
5, right? Promotion 5.
Promotion 5.
Then We have another one.
Supervision.
Supervision how much? How much?
6.
So that means we have 3625.
Payment maybe 7, sir.
Huh?
Do you count?
No. 1, 2, 3, 4, 5, 6. It's 6. Just only the number is not in the same sequence. Just 6. Yes. So we have 3, 6, 2, 5.
Including the
EY2,
EY1,
3,
7.
6, 4, 7,
Which
1,
one?
5.
Payment.
It's not ascending, but
2 is not there. 2 is not there.
no, sir. It's there.
is there?
Is there?
The last
How about
one.
the
The
last
last
one?
one.
Just
The last one.
2,
Yeah.
3, 4,
5,
5,
6, 7.
6. Okay, make 7. This one payment. Okay, 7, right? Now this. So this now draw it. So to draw those figures, you just do the use. You go to this one, you click on this one, then you come here. You say this one for the payment. We make 7. You click 1, 2, 3, 4, 5, 6, 7. Then we come to the second one. We say 6, right? 1, 2, 3, 4, 5, 6. Then this one, 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So now to move these figures, because now they are inside each other, right? You just use this circle here. Click on this one. Now you click inside the circle. See, you can move it right, left. So also they are still linking to each other. What you will do, you click on this figure here. These 3. You click on these 3, then you go to the lorry. You take the lorry, then you take them like this. Arrange. Okay? Use lorry. Here. You don't have lorry, check if there is any motorcycle. Okay? So everybody draw this one.
Should we keep space between each other or
Just little bit space, like here, space. So you done it?
No, sir.
Done? Have you done it?
yes?
Okay, done? Done. Okay, now this is now what you need to write. You click here. You need to click here. You write the name of the variable inside. Just say here by me. Okay. By. Tamam.
How to do it?
You click inside this one. Here you click inside. We write. What is the second one? The sixth one. 6 variables. The justice is, we said also 6, right? Then we go to justice. Then, what else? This one. Supervisions. Supervision. Then we have we said 3. 2, 5, right? Okay. Then supervisions, promotion here. Promotion. What else? Oh, job satisfaction, right? Yes. Oh, next one. Delete this one. Promotion. Okay, now this one, for example, is not heated. Just you can do like this. You go to this one, you increase it. Okay. So just try to click on this one. When and then click again. Now it's not valid, right? Go to your lorry. Try to tight this one little bit. Like this. I mean, try to withdraw it. Okay. So now you need to do what? We need to draw the covariance. Or first we need to write the name of the variables here. The name of the item. You go to this one, you go first to the data here. Because we don't have data still inside this one. If you check here, no data, right? It's empty. So you go to file, this one. Select data, then file name. Then I go to AMOS, IIiBF workshop, AMOS workshop. Then I select this one. Now the data will be inside. Then click OK. Now when I go to this one, I found the variables already here, right? Because I already key the data. You want to key the data from here. You go click this one, file name. You select the file from the one file I give you. This one IIiBF workshop. Okay, then You go to this one, AMOS, huh? Go AMOS, then select the file, this one. Then you say okay. So now we have, in the file, we have how many? 250 observation. So then you just say, okay, here. Now the variable's name is already there. You check here, the variable is already here. Everybody found this one?
Can you repeat?
Repeat which one?
How to include the file?
We said here. This one. Then we said file name. Then you go to your file, the one you said it, the file I give you, the workshop file. You click on the IIiBF workshop. Then there is two files inside. One for AMOS, one for, you click for AMOS, then you will find the SPSS file there. You click on the SPSS. Okay, like for example here, in my file, I keep the data here. But I don't know where you keep your data in your file, in your computer. Like, for me, it's like this. Here, IIiBF workshop, then AMOS, then there is one, what they call it, SPSS file. I click on it, then I said open. Then now the data will come here. Then I said okay. So then I go to this window, then I found the items already here. Okay? So now let's go to the second step because there is no time. Today is Friday, right? We want to break. And also we still have many things to do. We need to print the conformity, then we go for run the model, then after that we go for mediating and moderating. That's what you need actually. Okay, so that's why you have to be faster. Otherwise we cannot cover everything in one workshop. We need to do another workshop. And then we don't have, I think, enough time. So what you will do now, this is the items here. You select the items from here. Just I want to take this one here. You can put it here. Now we go to check here. This one is payment, right? Then I go to the payment. This one, BY1. Then I put it here. Just I click on this one. Then I keep click. Then I move my mouse to here. Then I say BI2. Then BI3. BI4. So BY5. B65, BY6, then BY7. So that's when I move the item for the payment from here to here. Then I go to the second variable, which is the justice. This one, GUS1. Just take it, click on it, then just move your mouse to this icon. Then supervisions. I go to SUB here, the beginning. Supervision 1, supervision 2, supervision 3, supervision 4, then supervision 5, supervision 6. Then I go to promotion. This one. PRM1, PRM2, PRM3, PRM4, and then PRM5. Then I go to job satisfaction here. GOS1, 2, 3, 4, 5. Okay? So now I have key all. one?
You did this.
No problem. You bring the another one, then it will leave in the case one.
After what?
Huh? No. This one is well this. Oh, this one you have to leave control here. And this one you need to delete. For example, this one, right? Okay, so everybody reached to this point? Not yet, right? Okay, so then after I key all my items here, what I will do, I try to draw the covariance between this and this and this. To draw the covariance, you can use this one, manual. Like each one should be here. Then from here also to be here. This one should be here. Then again, this one should be with this one. Again, this one with this. Right? So again, this one also with the others. Right? This is the covariance between all the items. There is another way. If you cannot do this one, just I will show you how to do it. Not manual, I mean just by the system to draw it. This is the scissor, you can use it to cut anything. So here you go, you click on this finger, okay, this one. Then make this one, click here, there, sorry. Here, then, okay. When this one is a below color, then you go to log in. Log in, then you click on draw covariance. Then the system will draw it by itself. But see now, when it draw the covariance, it make it on my draw, right? You try to modify, you try to change. This one, make it in this side. And then keep the covariance in the side. So how to do it? First, you go back to this hand, you click on the hand, then you go to this circle, you click on the circle here. Okay? So then I try to modify this one a little bit. Okay. Then this one should be like this. Okay? Or let me put like this. So now this is my covariance. I have drawn the covariance. I make the system to draw it by itself. So what I need to include also, I need to include the goodness fit indices of this model or of this measurement. So to include it, the goodness fit measurement, you need to click on this one, the title, the below color icon. Click here, then click inside this one. And then select here left to make it in the left side, in this side. Select here left. Then now you need to write the goodness fee formula here in order to be appeared there. Okay? So what you will do, you go to write here, for example, the first indicators will be, you write here k square, then equal, then this one, divide. The one with this, not the another side, huh? because they have two, right? Take the one with the slash in this side. Then right here, CMIN, okay? Then you go to DF, degree of freedom. Then make equal slash, then write DF. Then again, write norm K square. Then equal slash, then write CMIN, then write DF. Okay? Then again, write D value equal slash, then B. Then again, CFI equal slash CFI. Then you type also RMSE, RMSEA equal slash RMSEA. So this is the goodness fit indices that measure whether this those construct is valid or not valid. Okay. So then you say you click here OK. See, it's already here. If you want to move this little bit, just you can click on this one, the lorry. Then move it as you like. And the lorry is free. You can rent it anytime. Okay. So now it's okay. Everybody draw this one. I know you will face problem how to write these things, right?
Yeah.
But I already did it here for you in the slide. In the slide is there. In the slide, it is there. This one. K squared dV. This one you can write not K square, or you just write these things. Then you write this one. And this is the rule of thumb for each indices. Then B, CFI, and RMSE. Just type it from here, and then don't type this one in the formula. Just only the rule of thumb. Sorry, this is the rule of thumb. This one is the criteria. Okay? So now after I key all this information in the model, I go back to my...
Sorry, but just one. Just to do this, the lines. You in the beginning you create something in the payment.
Yeah, this one. You go to here, plug in, then draw covariance.
No, before there is a step before it.
That's one I did it manual. Manual just...
No, the manual. Just go directly to this. Then, okay.
Yeah, manual is use this one. Then you click from here, then you just draw like this. Like. But if you want not to do manual, I mean, you click on this finger, you make this one in yellow color, then you go for plug in, then you click draw the covariance, then it will draw. Okay now? I know some of you already lost now, but just try to focus on what we have here, then you try to practice it when you go back. So now what we'll do, just run it here. But when you come to run it, it will not run, because we have here the error terms and there is no values here. This one also error term is should given the name of each error term. Okay? So then, no, it's just one time when you do it, then it become easy for you. First time maybe you think there is a lot of things you need to do, but when you do it one time, two times, you will find yourself familiar with this. Yes. Okay, now let's do what? The name, we name the error term. How to name the error term? You go to log in, then here, name and observe variable. Name and observe variables. You click on name and observe variables, then you will see already given the name. Error term 1, error term 2, 3, and 10, error term 29. Because we have 29 items. Okay? Now, after we draw everything, we need to run it to see whether it is good or not good. Whether it is valid or not valid, right? So you come here and click on this one. To run, you have to click on this one. Now, the system will not run, you need to save it. You need to save the result or the measurement in your file. So what you write here, the measurement 1. Just write measurement 1. Measurement 1. So this measurement 1, when you need to save, when you can save it, you go to save it in your workshop file in the AMOS. Okay. So you go from here, just right. You can select from here. You can save it in. For me, I just saved it in my. You select from here. For example, me in IIiBF workshop file. This one. Then I go to AMOS, and then I make save. So now the system, see, they will start to do calculation here. Because, see, when this one is appear, that means that the correlations start working.
From where you do the running?
Which one? This one?
For errors, yes.
Run from here. Yes. So here they said variable name job satisfaction is invalid because it consists an individual character. Okay, let's check what the problem with this factors. Here, job satisfaction. Why it's not valid? Because there is space. See, I wrote here, job satisfaction should not be any space.
Very stupid.
Yeah, just eliminate the space, then it will run. Here, just I eliminate the space like this, then I say okay. Now I try to run it again. Just see here. I click on this one to run. Now it starts running and not need to save because we already saved it there, right? Now you have to light here, the traffic light. This one to invalid the work here, and this one to show the result here. Okay? So now you click on this light or this green light. Then you select from here, you have unstandardized and standardized. Select the second one. But see here, the result when I click on standardized is not appear. Why? Because when I select from the output here, you go to this one. You have to choose which type of output that you are looking for. Here, from output. You go to output. This one, output. Then I need to select standardized. You select standardized. This one also square if you are looking for. And then modification. Then I click on this one again. Now I run it again. Then the result will appear for standardized because I already select the standardized from the window. So now see again, I click here, then I select standardize, the result already here. So this one is the covariance, this one is the factor loading, right? But now to check the validation of this result, to check the validation, I have to look for what? Two things. For the factor loading and the goodness fit indices. To confirm these factors are valid in my model. Two things you have to focus on. Factor loading and the goodness fit indices. In factor loading, the rule of thumb should be more than 70. This is the rule of thumb. Should be more than 70. But they said in such literature, they said more than 50 is acceptable. Then you have to check one by one. If you cannot, I'm sure most of you cannot see these figures, right? You can use this one who's, I mean, anyone has a problem in his eyes, can use this one. Now we can check. Okay? See now, this one is what? The factor loading. This one is 170, 80, 95, 88, 85, 86, 85, right? So this first, the first factors, the factor loading is more than 70. So we don't need to drop anyone, right? Then we check the second one. Job satisfaction. Also all of them more than 70. Then we come to supervision. Here in supervisions we have this one 67, 69, 67, 57. You remember last time when we found those, there is a cross loading when we do the analysis, and see also here we find they have a problem here. Right? You remember when we do the exploratory factor analysis, we found those factors, those items, they have cross loading. So now when we come to confirmatory, we found also they have problem. So then we need to drop them. Either to drop them from there, or you can drop, when you come to confirmatory, also you need to drop them. Okay? So this one is weak, then we need to drop it. But let me check the others. This one, the promotion, right? Promotion also here, all of them more than 70. We don't need to drop anyone. Then I go to job satisfaction, also all of them more than 70. Only I have problem with this factor. So now in terms of goodness fit indices, the rule of thumb for norm chi-square should be less than 5. Okay? Here it's less than 5. It's 2, right? 2.42, which means acceptable. This one, the p-value should be significant. Confirmatory factor analysis, sorry, the CFI should be more than 90, the rule of thumb. And the RIMC should be less than, it is in between 0 and 80. Here it is 0.7, which means less than 80%, 0.08. Not 80, 0.08. Should be between 0 and 0.8. The RIMC. Here the RIMC is 0.07, which is still acceptable. But now you can improve this model. We can improve. How to improve? We try to drop the items that has low factor loading. So now this is one way to improve the model. If you cannot drop the items, you have to go for modification. You have to link the error tips sometimes to improve the model. But now based on this one, we just try to, we go, which one we say it is? Here. We have supervisions. We have number 1, number 2. We say we drop number 1 and number 2. Then you bring your scissor to cut this one. 1, then 2. Oh, sorry, yeah. And also here, this one you have to keep at least one you impose one for one items. If this one it's not existing, for example, I try to drop this one. Then these items I have to replace another items and impose the value 1. Otherwise, the system will not run. Okay. Okay. Now let me run it again. See now, the goodness fit indices is already improved. Become 91, before it was 90. So that's, and this one is become reduced. And this one also is reduced. This is the way to improve the goodness fit indices. If, for example, I keep drop here, but see here how many items you still have. This one now, the job satisfaction, see, it's improved. Becomes 68, 68, 72, 74. So this one is 68. It's also less than 70, right? I can drop one of them. But if I continue drop, I need at least 3 items in this construct. If less than 3, the system the construct will not run. This is the rule of thumb for AMOS. But if you use, for example, BLS can run with 1 item. Okay? But for AMOS, you need at least 2 items in the construct. So now if I go and drop 1, let me drop this one. Then I run it again. See now this one it become 91. It's almost 92, right? And this one is reduced also, and this one also reduced. But see this one. Okay, now let's just we keep those 3, because if we drop 1 more, it will not work. Okay, we keep those 3. So now based on these 2 indices, which is the what they call it, the factor loading and the goodness fit, is achieved. But now I have to go for validation. There is another. You remember when we discussed the validation, we said we use compensate reliability, the CR, and also we use the discriminate validity, right? To compare whether those items is relevant to this construct and also they are not relevant to the others construct. Okay? We call it discriminate validity. So what you will do now for discriminate validity, we go to, I give you here one file, this one, stat tool package. It's in your file. You click on this one. Yes. So I want to now to test the validation here. Validity master. So I need to paste here the correlation table from my result and the best standard regression way. So I go to my result. You check your result here. This is the result. To check the results, you click on this one. This one here only the result on the graph, but there is a table there. If you are looking for the tables, you click here. Then you will find the result. You click on estimate here. So our result is here, all the result. So what I need from this result, I need only, you see here, what they said here. they said phase correlation. Then I go to correlation. Here, this one, click on scale, circulars, then you click correlation. Then you click here on the right side of your mouse, then QB. Then I go back to my to this SPSS file. I make paste. So then I go to paste standardized regression. So then I go again to my file here. This one, standardized regression. Then also I copy it. So then I go to the Excel sheet again. Then I paste here. Then I click on this one, the red one. See now, this is the validation. The rule of thumb for validation, this one should be more than 60. Average variance extracted should be more than 50. And this one should be less than the MSB, should be less than the average variance extracted. And also, if there is any issue, like for example here, it will be in the red color. Then it will show you here what's the problem here. What they said here, they said discriminate validity, the square root of the average variance for job satisfaction is less than 1, the absolute value of the correlation with another factors. So discriminate validity, average variance for job satisfaction is less than the MSB. Usually this one should be more than this. First, it should be 50 and above. Then this one, this volume should be less than the average variance volume. So we have here one problem. Then how to improve this, how to solve this issue? What you will do? You have to go to the factor and drop the items that has low factor loading. Then this one will improve. Okay? So let's go back to our model. So then we bring this one to check the factor loading. We drop the weak one. See here, this one, 74, right? We drop this one, GOS1. Then here, bring the scissor, we cut it. Now we run it again. Close. Okay, let's go to this one, right? Okay. So this one is closed by itself. Okay, let's see. Data. The system is closed. I think can break. So we go to break, Jum'ah, then we come back. We do the validation, then we run the model, then we do the mediating and moderating. Okay? Okay, what's the time? We can 2:30 or to make it 3? 3, right? Yes, we come at 3. Yes. Want to give any?
So we have also lunch outside.
Oh, we have lunch. Okay, then you can enjoy your lunch. Then you go to break.
So we be done at 3, right?
Yes. So then please you can go and enjoy your food. Then we come after around 3. We continue. We do the mediating, moderating as well as the bath. Okay? Maybe it will take time, maybe around from 3 to 6. But we will try to do it early. You can maybe finish before. But I mean you have to expect to reach to 6 p.m. Those who has a plan, you have to delay.
Just you said روح نصلي لها صح؟
ايش اخر شيء غيرته؟ خلص مشقق هذا زي كذا والله قالت لي اياه من دراسه في سيوز بس اليوم قبل 5 لنا كمان
طيب احنا نكتب لك اياه يو ار اي فاينل داتا اناليسيس.
لا احنا خلصنا انا كتبت انا خلصت شغل He's like maybe doing final review.
So we said to test the reliability, sorry, not the validity. We need to check the result first here. To find the results, you have to click on this one. So from here you go to estimate, then colors, then you go for white, for correlation. Here they said best correlation, then here best standardized correlation. Then go for So we go to correlation, then we copy this table from here. So then you go back to your this one. Here we paste the correlation. So then we go to the another one, what we call it the standardized regression. This one. So then after that we go to the Excel table. Then you paste here the standardized regression. Then after that you click on this one, the red overlay. Then you will find the table here. So now we said we have such issue, right? So this one, you see here the average variance extracted for supervision is less than 50. So that means this variable not valid. So to improve the validation of the average variance extracted, you need to drop the items that has low factor loading. So then we go to, we have now two issues, right? Job satisfaction and supervision. Okay. For this one we go to supervisions. Okay. For supervision here, what's the problem here? If we check here, job satisfaction, we can drop COS1 here for supervisions. First one, SUB1, see, and then SUB2. Their value is very low, right? It's less than 70. So then we drop them. This one, supervision 1, and then supervision 2, then also job satisfaction. So now we run it again. See, now this one is improved, it become 91. This one we can also improve, become 0.77. This means it's less than 0.08. So now what we'll do, we do also again, we run the Excel, this one, the Excel sheet again. Here we base again the correlation after we drop those factors. To see the result, we can get it from here. Estimate, colors, then you go for correlation, to prove it again. Then we go to the Excel table, we place it here, then we go to, again to standardized regression, prove it, then we go to the Excel, we place it here, then we set it here. Now see, supervision still has problem, right? It is less than 50. So that means this factors or this variable is still not valid. So you need to do what? You need to drop also. You go again to the model, to the framework, I mean the, what do you call it, to the measurement. See here, we have this one 76, this one 76, so then we drop this one, SUB4, okay? This one SUB4. Now we run it again. See now the result. See now how much our CFA. It become 92. So that means it's improved, right? And this one is reduced, become 0.07. Okay? So that means it's improved. Now we go to check the validation again. Here. So we have to go to the Excel sheet again. Make here receipt. Then we go to our data. Here the correlation. Then we go to it again. Then we go again to the Excel sheet. This one, huh? Then best. Then again, we go to the standardized regression, movie, then we go to the Excel sheet. Okay, so now we run it, we see. Now no more any red color, right? So that's mean the what they call it, the requirements for validation is achieved. This one is more than 50, all of them more than 50. This one more than 60, and the MSP is less than AB. You see here, this one 61, this one 63, 62, 70, 61, 65, 44, 50, 62, 64. This one should be more than MSP. Okay? If there is any problem with the validation, you will find it in the red color. But you see here, no validity concern. So that means there is no any more problem with the validation. So then you have to use only those variables in order to estimate your. See, now we need only to use only those items to estimate our hypothesis with those factors. Last time we have many factors, right? Many items. Then we drop the one is not valid. Okay? So this is only the one we can rely on in order to test our hypothesis. So now we go to the second step, which is measuring the hypothesis. Because why we do research? Because we want to examine our hypothesis to prove our hypothesis or reject, right? Now we reach to this point. What we are doing from morning only to screen the data to achieve all the requirements of the data. So now we go to draw here. We need to draw what they call it, draw the path coefficient. So this one we can save it, make save. We call it measurement. Measurement 2. Okay. Now I need to change this data. What you will do first, you will cut all these things. You don't need to draw it again, just cut these things. So now our dependent variable is what here? Job satisfaction, right? And this is the independent variables. So then you can just take this one. Just take this one here. And this one also here. Bring this one, then you just change the figure to this side. So now we draw our hypothesis. So to draw the hypothesis, what we will do? This one you can make them together. So to draw the hypothesis, we just use this one arrow. Then just go like this. So this variable we call it endogenous variable. This one is the exogenous variable. So for endogenous variable, you need to find the error to find the error term for each endogenous variable. So to do the endogenous variable, you click on this one. See here, click here, then what is here? Then so then you need to rename this one also because it's empty, right? You go to login, then name and observe variables. Now already write the name. Then after that, you need to also colorate the relationship between, to draw the covariance between the independent variables, right? So here we need to draw the covariance. So for covariance, you just use this one, the two arrow, like this. Okay, so now this is what? The covariance between the independents. Why we can, now if I try to draw this one, for example, as a covariance, it will not work. Why it will not work? Because this one is not exogenous variable, it is endogenous variable. Okay? So now we try to run it because our main target to establish this model to examine the hypothesis. This is the hypothesis 1, 2, 3, 4. Which one? The one we have one error only. So now what you will do, you go to this one here, you ask for calculate. So here supervision and promotion. Okay, now we need to draw also the covariance between supervision and promotion. This one. Okay, we run it. See now, this one 92, this one 2.04. I mean all this, the requirements for the model, the goodness fit of the model is achieved, and this is the hypothesis result, the estimation coefficient. To determine, to check the significant level of the estimation coefficient, you need to go here and check in the result. Result is here. Estimate here. This is your result hypothesis. This is the only the four hypothesis, which is payment with job satisfaction, right? The effect of payment on job satisfaction. This is what? Here. This one is the p-value. You have to check the p-value. This one the estimated coefficient, and this one is the p-value. This one, if it is this than 0.05, we consider is significant. If you see here now, this one is what? Significant, right? Because 3 star print is 100% significant. This one is this than 0.05, also significant at one level of significance. This one also with one level of significance. So we found 3 variables are significant and one is not significant. And if you see that this one is negative, the others is positive relationship. So that means the payment has positive impact on the job satisfaction. Then the supervision has a negative. Supervision has a negative effect, but statistically insignificant. So if you are working in that organization, you have to make decision to change the supervisor because he contribute negatively to the employees' satisfaction. Okay. So then justice here is significant and positively. So that means when you find the justice system in your organization, then people they feel more satisfied. And then promotion also, if you increase the promotion, then it will increase the satisfaction level with your employees. Okay?
How to know if it is significant or not?
Because based on the B value. The B value here is B value is what? Significant, less than 0.05.
Less than 0.05?
Yes. Okay? This is the B value. This one is the estimated coefficient. Like we have done in OLS, sorry, in regression, SPSS yesterday. You remember? Yesterday we found this table actually when you use SPSS. If you want to use SPSS and then you compare the result, this with SPSS, then see how it's different. Okay? In SPSS we found all significant and this one is positive. But when we use the what they call it structural equation modeling, we found only 3 significant and 1 is negative and statistically insignificant. So if you rely on SPSS, your estimation will not be accurate. You need to use SEF.
Do we need to perform the CFE for each variable separately, or?
What you mean CFE? Confirmatory?
Yeah.
Yeah, you can. First you have to do it individually. Then you make combination.
Covariance.
Yes. So now this one is clear. This is what you are looking for from this analysis. This is your final result. This is your final result. Okay? Because we have 4 hypotheses here. 1, 2, 3, 4. We hypothesize those factors have a significant influence on job satisfaction. But then when we come to the result, we found only 3 significant and 1 is not significant. Okay? So now after we run the batch coefficient, now we need to learn how to the mediating and the moderating. Because each PhD student, I think, they have this type of variables, right? Most of the PhD students, they have these variables, mediating or moderating. So which one you would like to start with? We start with mediating?
Mediating.
Okay. So for mediating, we have here, this is for mediating, this is the relationship how it should be, like this. And here we have dependent and here independent. This one DB, this one mediating, and this one is DB, sorry, IB. Okay? So this one is the direct relationship. IB has direct relationship with DB. This one indirect. Sorry, this one not. This one also direct. IB has influence on mediating variables, and also at the same time, MP has direct influence on the DB. Okay. So now I want to examine whether this variable is mediator or not. So to measure the effect of these mediating variables, you need to find the indirect relationship. This one we call it indirect relationship. Okay? So now when it comes to the rule of thumb, how to say this one mediating or not mediating. If you find this one direct is significant, first if you find this one indirect, okay? Here. Indirect. This one is direct. Indirect also, this one direct. If we find that indirect is significant, then we can confirm this one is moderating. What is indirect? The indirect coefficient. Like when we draw now, we found the coefficient, right? So when you find the indirect coefficient is statistically significant, then we confirm this one mediating. But there is two types also of mediating. There is full mediating and there is partial mediating. We have full mediating and partial mediating. How to say partial or full mediating? If you find the direct is significant, see here for example significant, and the indirect is significant, so then we call it partial. Okay? When the direct significant and the indirect significant, then we call it partial mediating. If we found the direct insignificant, here, insignificant, and this one is significant, then we call it full mediating. Okay? This is the way how to determine whether the variable is partial or full mediating. So now we want to learn how to find the coefficient for each one, for this relationship. So now let's assume what in our model, we assume that payment, or let me see here what we have in the model. Okay, let's say we assume now the mediating, the payment work as a mediating. Supervisions and the direct effect between supervisions and the job satisfaction, we have direct. Then we consider this one as a mediator variable. Then we see whether it is really play as a mediator or not. So to do this one, what you do first, let's go to eliminate. Cut the things like this. So now we just draw from here to here. See now this one it become what? Indigenous variables. We just click here. Then name and observe variables. This is the same what we have here, right? We have mediating. This one is the direct, right? It's actually what we draw here, right?
Yeah.
So now we want to see whether this one is play as a mediating or not, based on the estimation coefficient here and here and here, the three estimation. And then we find the indirect between this one and this one. If the indirect significant, then this one is play as a mediator. So now just we run the model normally, but first you need to go to the output window. Then you have to select the this one, the indirect effect, because this one it will show you the result of indirect. You have to click on this one. Click on indirect effect. Also, you need to calculate the bootstrap here. You need to change from 200 to 2000, and this one from 90 to 95. So what you will do, you go to reform bootstrap, you click here, then you will change here with just 2000. Then again here, basic corrected confidence interval, make it 95. Okay? So now we just say, okay, now we just run it again. Okay, so now we run, see the result. See now this is the result. This is what the estimated coefficient. The direct become not significant, right? When we run, we found the supervision doesn't have significant influence on the job satisfaction. So now this one is significant and this one is significant. To find the estimation coefficient for the indirect, you will times this amount with this amount. 185 times 148. Then you will find the estimated coefficient of indirect. Like here, it will be how much? You see here, we make the first the direct. The direct is repeated. How much? 109. 109. And then it is statistically insignificant, right? We will check how to find statistically significant or not significant. Here, 1.85. This one is significant. Just make 3 stars. Then from there to there is 1.47. And also is significant. So now to find the indirect estimated coefficient, we'll just say 0.85 times 0.48. Anybody can do the calculator? Can you calculate this figure? 0.85 times 0.47.
Point
47
.47
times 0.85.
equal .3995.
3995. Okay, so this is the estimated coefficient. Now to determine the significant label, because here this one is represent the t-test. You can go to the t-table, you will find the significant label. But the software also is provide this information because we have done the bootstraps. We include the bootstraps here. So we go to the result. So here you select estimate, then in estimate here, here, subclubs, okay, see here, this is what? The direct and indirect effect. Okay, for direct effect, this one, indirect effect. This is what? The estimated coefficient. This is the direct effect. The direct effect, we have here job satisfaction, right? And this is the independent variables. If you see here, this one, we are looking for only for supervisions, this one. Supervisions with job satisfaction. This one, job satisfaction. How much? 0.504, right? How much there? The direct? 0.05. Okay. Then the second one is what? This is what? Indirect or direct? Oh, the indirect effect, sorry. We select the standardized. Standardized indirect effect. This one. 0.401, which is this one. This one actually 0.4, right? 0.4, yeah. It's the same here. But because you didn't include all the decimals, so it will be the same here. This is should be 0.40. Here, 0.401. Okay? Insignificant. And this is the value here. Okay? This is the direct, the indirect effect. But to determine the significant level, you have to use the bootstraps. If you see here also the others, we have here also the direct. Let me check the direct first. This one, direct, standardized direct. This one. For supervision, how much? See here, supervision. See this one supervision, right? This one payment. And this one job satisfaction. Supervisions on job satisfaction, 0.09, right? You see here? 0.09, right? Because we didn't include all the decimal there. Then the second one, now we cannot say significant. This is not the significant. This is the estimated coefficient. We will come to this one, supervisions on payment. This is the payment. Then we see the supervisions here, 0.85. 0.85. Then also payment on job satisfaction, 4 seconds. This one, 4 seconds. Okay? Now this one times this one, you will find this figure. But now we don't know whether it is significant or not significant. So to check the significant level, you just use this one. Bootstrap, then you click bootstrap, then you select 2 tile significant. Now it will give us the result of the significant level for all. This one, supervision with the payment here. So this one is significant because why it is significant? Because it is less than 0.05, right?
Yeah.
Less than 0.05. Which means here it is significant. For the second one, supervision on job satisfaction, not significant. This one, not significant. Not significant, the direct. Then, payment, this one, payment on job satisfaction, significant. This one, significant. Right? So now we want to check for the indirect. whether this one, the indirect, right? This figure is the estimated coefficient for indirect. We want to see whether it is significant or not. How to find it? This one. You go to here. This one indirect, right? Standardized indirect effect. Now we go to this one, job satisfaction, right? And this one is supervision, the indirect, which is from here to here, the indirect one. This is the estimated coefficient, and this one is the significant label. So significant label is 0.002, which is less than 0.05.
Yeah.
So that means it is statistically significant. So now, see here, this one is significant. Let's make 3 steps like this. Significant, right? But the direct is insignificant. So now we call it, first when this significant, so that means this one is mediator. But now to determine whether it is partial or full, you have to look for the direct. Direct now insignificant, but the indirect is statistically significant. So then we consider it full mediated. Okay? So this is the way how to test the mediating. Okay, now this one clear? So this is the way how to run the mediating effect. Now we go to test the moderating. I think the mediating is clear. If anybody has question about the mediating? No, right? Okay, alhamdulillah. Then we go for the second. Okay, now we go for moderating. So the moderating is what is little bit different than mediating. When we draw the mediating, in mediating, this one should be in between, right? The relationship between supervision and job satisfaction. You remember when we ran supervision to job satisfaction, it was not significant, right? In our model. When we do the mediating, it becomes significant through the indirect, right? It becomes significant. But when it comes to moderating, the relationship is not, you need to do what? You need to test it in this way, here. It's not in the middle. It's just include in the model to motivate the relationship. But the relationship is already there. Okay, but motivate or decrease the relationship. So what we will do now, we need to measure this, assume now which type of model we can include. We can include the gender as a moderating. It can be categorical, it can be continuous variable. This first we take it as a gender, as a categorical variable or nominal variable. We select here gender as a moderating. So then we come to run it. So to run the moderating, you need to do what first? So to test the mediating, you need to segregate your data. This is the first steps you have to do it. You need to segregate the data to two categories. First one is like our data is like this. Our data is here. We have 250 respondents. So to test the effect of moderating, you need to segregate the data into two groups. Group A and Group B. This one is, we call it, let's say here male. This one female. Then we segregate the data. We want to see how much male, how much female. Then we see whether the gender has effect relationship or not. Okay? So now we segregate the data using the software. So here you go to here, group. You click on group number, then write here the group 1 male. Then click new. Then we write female. Then we close. Now see, we create two groups, male and female. Yes. So then, what you will do, you go to transform your data first. We open here the data, then we say data view, view data. Okay. So then you go here, transform. This is what we have done yesterday, right? Then record into different variables. But because some student was not there, or not here, yesterday, so we need to do it again. So here you need to transform the data. So our data, we need to transform the data only for the mediating, not the other variable, or which is the gender here in our model. So you click on gender, put it here. Now you write the name of the new variable. We say GM, which means the gender mediator. So then we go to the change of the values. We go to the range. So write from 1 to 3. 2, 3 as low. 1. Not low here. Just one. Consider it as 1. Yes. Then add. Then from, oh sorry, here you don't need to transform the data because, sorry, cancel. You don't need to transform the data because the data already categorical. Because when we go to male, to the gender, it's male and female, right? See here, this one, the values. When I go to gender, this one, right? If you see here the values, we have only 2, 1 and 2. But that's one only if your variables is continuous, you need to segregate and then transform the data. Here only just to create 2 groups, male and female. The one we create early here. Here you don't need. This one we already just only create 2 groups. So now what you will do, So then we go to, we have here male, female. So we go to run the model. Just run the model. Okay, you have to key the data first. You key the data here, then grouping. So you go to gender here, this one. You click OK, then select here. This one for male. So that means the number of respondents for male is 186. For female is 66. Yeah. So then for the first group you click on 1, then make OK. Now this is gender. 1 which refer to male. So now we go to the second group. Then we select the file again. You have to key the file every time with each group. Now we click on this one, okay? So now we go to grouping value. I have to select the variable again. Gender, this one. But now we need to define the group. Group value, we make it 2 for the female. Now see the data already segregate. We create like two files. The first file is 180 and the second file was 61. If you check before, there is only one group and the data is 250. Right? Now we already segregate those two groups. Then we make OK. So now we run the model. Okay, we run the model. Very slow, huh? Because we make the bootstraps and we didn't delete it. That's why it takes time. More than the normal. Because when we did mediating, we click on bootstrap, we make it 2000. So now it takes long time. That's why we need to go back to this file. We have to go back here, then we click on bootstrap, then it will be faster. But now it's hanging. You have to be patient. go back here. 150. Make it 200, okay? Click on this one. This one also change it to 90. Then make it 8. So then we go to this one again. What is meant to do? Okay, we go to the Excel here, the Excel table. We click on this one. Then just click here to receive. We go for difference group. Then again we go to this one. Output. We go and click for the critical ratio. Here. Because we need also to report the critical ratio value. Now we run. So we go to the results here. Then we estimate here. We go to the scales. So if we go to the Excel sheet here, what they say? In the Excel sheet they said you have to copy the best regression weight table table in A2, this here, and A2, and also best the regression weight for table in table 2. So in G2. So now we go to the regression for both male and female, because now we have two models, right? We run the model separately. The first model for male, the second one is for female. Because we segregate the data to two groups, right? So now when we go to check the result for the correlation for male and female from here. This one. This one, weight regression, or we have to do the standardized? No, just regression weight. So you go here, then you go to this one regression weight. But which group? Here. This is regression weight, and then we have male and female. So you click on male, then you copy this table will be regression weight for male. See here, this one. Click here, and this is the regression for male. Then copy. So I go to the Excel sheet, then I paste it here, the first group. Then I go again to this result. I click on here, female. Just click here, female. Now we copy this file again. This one is for female now. Copy it, then we go to regression 2. Then we'll go again here to copy the critical ratio matrix. So to find the critical ratio matrix, you need to go to the AMOS, and it's here. Fireways, parameter, comparisons, then you go for critical ratio. You click on critical ratio, you will find this table. And you need to copy this table. Copy. Then you go to the Excel sheet. You paste it here. Okay, so now we paste the three table, right? The critical table and the weighted regression for both male and female. So now what you will do, you need to click on this one. Click here, then it will do the calculation. Okay, now this is the result. The result is, what is our hypothesis? Gender moderate the relationship between supervisions and job satisfaction, right? So now this is job satisfaction and this is supervision, right? This one. Job satisfaction and supervision. And if you come to see here, male and female, for male is significant, sorry, not significant. For female is not significant also. Both of them not significant, and also here it's not play as a mediating. But in terms of payment and job satisfaction, if we change this say here instead of supervisions, we make this assume our hypothesis is the gender moderate the relationship between payment and job satisfaction, right? We assume like the payment, sorry, the gender moderate the relationship between payment and job satisfaction. If you see here, this is the payment and this one the job satisfaction, right? So now, based on the mediating, here it is significant. Okay, there is interaction. So here, when it is insignificant, sorry, it is significant. The z-score is significant when compared to population mean, male and female. We found it significant, but now we want to see which one is the more affected, whether male or female. So if you see here, for male is statistically significant. For female is not statistically significant. So that means what? For male is the payment is more important to be satisfied than female. Okay, but in terms of, for example, when you come to promotion here, promotion also is play. The gender play as a moderator between jobs promotion and job satisfaction. But if you come to check here, which one is more interact, whether male or female, in this relationship, you will find the female is promotion for them is more important than payment. So they feel more satisfied when they get high ranking in the job. But male, because maybe the man usually they have high responsibility, they give the priority to the salary, right? But women maybe they don't have responsibility. No, they don't have responsibility, but I mean this is the nature of the people, I mean the perception. So then here the female they prefer to get more rank than salary, for example. Okay? So then here what you will say, how to interpret, you will say gender play as a moderator variables, because it's moderate the relationship between payment and job satisfaction. However, the interaction is from the female side is more than the male side. Okay?
Yeah.
So this is the way how to find the mediating and moderating. Okay? Any question? No, right?
Very interesting.
So now let's assume we still have, I think, 40 minutes. We can just continue. Let's assume now our mediating variables is not categorical. It's not, nominal or categorical. Let's assume it is continuous variables, right? So now we assume here our mediating is our moderating variables. Let's say the supervision here, or let's say promotion. Promotion is DRN. Is considered as a moderator variable in our model. So what you will do to test the effect of promotion as a moderator, you need also to segregate the data. But here there is no male female in this model because our the data of this variable is continuous variable, like Likert scale from 1 to 5. So what you will do, you need to create low and high. Low and high data. You have to segregate to two groups. Then the first group we call it low, the second group is high. The low usually is from 1 to 3. And the high is from 4 to 5. Right? Because the low, like the one who disagree. And from 4 to 5, the one with agree. So now we try to test this type of data. Then we close this one. So here okay, this one we delete now. This is delete. Then this one just we make just write group 1, okay? Oh, sorry. Here we make, instead of male, female, we just make low is, low is group 1. Then high is group 2. High. Okay? So now we create two group, low and high. But now we need to transform the data because promotion is, we said, is a continuous variable. You need to segregate it. So to segregate it, what you will do, you go to the data first. Let's say here, this is the data. Then view data first. Okay, what we'll do, okay, we go to transform, then compute, compute variables, not compute, transform, then you go to record into different variables. So now our variables that we need to change is what? promotion, right? Then we put it here. Then we write here PRM/M as a moderating, right? Then we go to change the values here. We make it range from 1 to 3. We make here the value is 1. Then the second one is from 3.001 to 4 to 5. We make it 2. So now the system, the software were already changed.
So, can you just again this process?
This one.
Good.
You do this
Record
one.
here.
Here. This one, we select the promotion, we put it here, then we go to here, change the value.
Alright.
Range, make from 1 to 3, then, okay, let me just remove this one first. Here. Now we do it again. 1, 2, 3. You select range from here. Then you make here 1. Then from 3, 1, 0, 0, 0, 1, okay? Oh, sorry. From 1 to 3, we make it 1. Then from 3.0001 to 4, so the 2.5, we make it 2. So now the system, any values less than 3, the system will read it as 1. They make it one group. The values from 3 and above will consider it 2. Like male, female, right? We have 2 groups. Here also the same. So then make continue, then make okay. If you go now to check in your data, you will find new variables. You go to here, variables view, you will find here new variable, this one. If you click here, you will find the data. See, we have only 2 and 1, no more 4, 3 and all these things, right? So now we go to test. You make save first for this one. You have to save it in order to the system read it. Make save. So you close this one. Or just keep it here. Now let's go to here. We go to group. Okay. So you cancel. This one cancel. What you will do, you go to here, view, you go to group, you go to the last variable that we create now. What's the name? Where is the variable not identified? Here already, so then just so now we go to group, should be here. Okay, now we can get it. So now we go to the last one. It's not here. Okay, we go to the file here. Analyze. It's already here. Why is it not working? Group. Okay, let me go to the data here. We change it from here. We go to this one is here. So say here. This is the variable now. Okay. So now we go to group value, which we select one. So this means the lowest is the low is we have 72 observation. Then we say okay. Now we go to the second one. We go to file. And then we select the file again from here. Then we go to grouping value. We select the promotion. Where is it now? It's not here again. So we go for that. File. We go to the D. Then we go to Team Portfolio. Again. Then we go to Workshop. And this one. Okay, now we can take it from here. This one. Then group. Then we select the second one. So now we create two files, right? This one 72 observation, and here we have 178. The total is 250. This one is, we call it low group. This one is high group. Okay. So what you will do now? Say now, okay. Then we run it. After we run it, we go to the Excel sheet. We go to the Excel sheet here. Here. We go to difference group. We select difference group. Now we base the regression weight table. You see the regression weight table. Regression weight, then we go to our result here. Estimate. Regression weight. Now we have, see here, we have low and high, right? Then we select first for low. Then it could be this regression table. Then you go to the Excel sheet. Then paste the value here. Then we go to the regression, to the model again. We select regression weight, but for high. Now we go here, we copy it. Copy, then we go to the Excel sheet. We paste it here. So then we go to the critical ratio. Come back to our model. We go to this one, pairwise parameter compression. Then click on it. So here we copy this table. Okay, so we go to the Excel again. Then we paste it here. So then we go to, then we click on this one. Then they do the calculation now. So based on this one, see here, it shows there is no z-score here is not available, the value of z-score. So anyway, this is the result here. If the z-score here is show any significant value, then we can consider the promotion as mediating variables. Okay? But you want to see whether from the low or from the high side, you have to check the probability here. They say this one is significant, this one significant. So here there is no difference. This one is not significant, this one not significant. So that means there is no difference. This one not significant, but this one is significant. So if you see here, job justice and job satisfaction, promotion maybe is play as a moderator variable. Because when there is justice, then people they can get their promotion. But if there is no justice system, so you will keep work in the organization, but nobody will appreciate your work, right? But if there is the justice system, they will appreciate your work. Then you will get high rank. Then also you will be more satisfied in your organization. So this one is significant with those who said agree. The promotion, I mean the justice is significant to employee. So for the here promotion, what else? Promotion and job satisfaction. This one, the direct one. There is no significant because we are considered this one as a moderate, not as a mediating. But I don't know. Actually, it's supposed that this score here to appear to determine whether it is mediating or moderating. But the most important, you have to learn how to do. If we run it several times, I'm sure that we can solve the problem.
Or let me just do it again. Maybe there is such.
You sure? Well, I think the time is already done, right?
Yes.
So then, do you have any question? But we have already run it based on the categorical variables, right? Based on the gender. Do you have any question for this? For mediating and moderating? No. Anybody has any question for how to test the mediating or moderating?
So for the moderating relationship,
Thank you. I have class.
for example, in this case, so already the independent variable affect the dependent variable. Okay. So we do the moderator variable to distinguish whether male or female has the greatest percentage.
Yes. And also sometimes this one is insignificant. Then when you include these moderate variables, it becomes more active. I mean the relationship is become high. I mean significant. Yes. So no more question. So then I think we have done for today. And now we give the speech to brother Dr. Hafiz. To conclude.
Yes, so thank you very much. I hope you all enjoyed the training. We'll be organizing more training, as you know, inshallah, as time goes on. Alhamdulillah, our doctor is always ready and willing to help. The fee was just a way to, just a token to organize some things. For him, he just did it as Sadaqah Tijariya, and I will continue to reward you. And from the society, please, we have this for you. Okay. Please come. Can we take this with you, please? Behalf of the president of the society. Yeah, smile like this. Good. Okay, can you please come? Usually we take picture with the lecturers. I mean, for those who are okay.
All the group?
Or for all the guys, our compulsory and the ladies. Okay. Rafael, you want to have the video? Please come, you can join. So they don't think it's only for men. It's not like a men training. Don't want you to stay beside.
you. Huh?
Thank you.
Inshallah.
Okay.
We need one more talk about